Hello. So in the last videos we have discussed about central orbits and when the forces depends only upon r, okay, or it depends only upon u, because we know that r equal 1 by u, and we have seen problems where the forces F it's equal to say 1 by u square or mu by u square or mu by u cube, okay, and so on. That is, the force depends only on u where mu is a constant. In those cases, if you remember, what we had done is there was a step where we multiply everything by 2 du d theta. Okay, so but what happens if the force also depends on theta? Okay, for example, u square cos square theta, let's just say, where the force depends on u as well as theta. That is when multiplying by 2 du d theta, it won't solve anything, okay, as we shall see. Okay, I will actually discuss the whole problem by using an example, okay, but the same techniques follows. There will just be a bit of difference here and there, okay, but the technique holds. Okay, so let's see, a particle of mass m moves under an attracting force equal to that, okay, with a velocity root 2 mu by 3a from an apse at a distance a. Okay, first we have to find the path, and also if you notice there is an extra question that the time of complete revolution is given by that expression. Okay, so first let us try to concentrate on finding the path. Okay, and remember that in the formula below 1 2 3 4 5, f is actually the acceleration. Okay, so solution. And if you notice the question, it involves only one part. Okay, so h will be the same throughout. Okay, if two parts are involved, then h will be different, p will be different. Okay, but since we have only one part, then h will be the same. Okay, it will stay as h only. And because h is a constant, we can actually use its value at the apse. Okay, solution h equal pv. But because it is a constant, I repeat, we can even use the value at the apse. P, if you remember, will be equal to the radius, which is a. And if you notice, the apse is at the distance a, that is why. Okay, and v, if you notice the question, it is root 2 mu by 3a. So this is what is happening. Okay, so now let us just find h, root 2 mu by 3a. And if you notice, because we are going to proceed from formula 1, okay, because it involves theta, if it involves dp and dr, then we will have to use formula number 2. Okay, but since it involves theta, we have no choice but to proceed from formula 1. So we will be needing h square, so we'll be okay, I will calculate directly. 3. So h square will be equal to 2 mu upon 3. 2 mu a. Okay, so after this, what we will do, okay, we will start with formula 1. H square u square d2u d theta square plus u, and we can actually, okay, it's better if we write this one to the right hand side like this. It is the same thing, obviously. Okay, so now let us substitute the value for h. It will be 2 mu a upon 3. U square will stay as u square. This one will stay as it is. Okay, so first let us put in the value for f. F, if you notice the question, it will be equal to mu m sine square theta by r square. Okay, but r square, you can bring it upwards, it becomes u square, again since r equal 1 upon u. Okay, so u square and u square will get cancelled, mu and mu will get cancelled, so we will be having d2u d theta square plus u. Okay, and m won't be there because it is the acceleration. Okay, force equal mass times acceleration. So we will be having 3 sine square theta upon 2. So we will be having this. Okay, this is the step that I say you have to be very careful, since now over here we have a function of theta as well. It not only depends on you but on theta as well. And if you remember, when we reached this step, what we did was we multiply both sides by 2 du d theta. But that cannot be done here. Okay, we can do this if the right hand side only depends on u. But again, I repeat, this one depends on theta. I will just write down how much the gut edge to be. Okay, in case I need it again. Okay, so we got edge to be this much. Okay, so this one, what we will do, you notice that this one, it is a second order differential equation. Okay, it is a second order differential equation, so we will have to find the complementary function as well as the particular integrand. Okay, so the complementary function is, if you notice, okay, just to be clear, it is of the form d2y dx squared plus y. Okay, it is of this form equal fx. Okay, so whenever you have something that looks like this, okay, instead of y and x, we are having u and theta, of course. Whenever you are having something that looks like this, we will have to solve it as a second order differential equation. Maybe I'll just write that over here, second order d. So the complementary function, it is m squared plus first we have to find the auxiliary equation. Auxiliary equation is m squared plus 1, it's equal to 0. So m will be equal plus minus I. So therefore the complementary function, okay, if you remember the theory about second order differential equations, it will be equal to a cos theta plus b sine theta. Okay, some used to write it as C1 and C2, it doesn't matter, but I prefer to write it as A and B. A, B are constants. Now we just need to find a particular integrand. And if you notice this one, it can actually be written, okay, pi equal 1 by d squared plus 1 of 3 by 2a sine square theta. Okay, the constant, we can even take it outside. Okay, sine square theta, if you use the formula for, we can use the formula, we can write it as 1 minus cos 2 theta upon 2. So this is what we are having. Next, what we will do, okay, we will just have to calculate it. Okay, I won't need it anymore. 2, we can even take it outside. So this one will be equal to 3 by 4a. 1 by d squared plus 1 of 1, it will be equal to 1 only. And 1 by d squared plus 1 of cos 2 theta, if you remember how we calculated, we will substitute minus 2 over here. It is not a bracket. And over here we will still be having cos 2 theta. So this is what we are having. Okay, just let me check. Okay, I've actually written down everything. Okay, so this is what we are having. So the pi, particular integral, will be 3 by 4a into 1 will be 3 by 4a, and over here we will be having minus 1 by 3. Okay, this one, it becomes plus 1 by 3. So that is why it becomes 1 by 4a cos 2 theta. Okay, so it becomes like this. So therefore, okay, I'll write it here. The solution to the second order differential equation 1 is u equal complementary function plus the particular integral. Okay, so we have got what u is. Now we need to use, we still have constants a and b. We need to evaluate the constants. How do we do that? By using the value at the apse. Okay, and if you remember, at an apse, du d theta equal to 0. Okay, so first we will need to differentiate it with respect to du d theta, with respect to theta. So you will be having minus a sine theta plus b cos theta. And over here we'll be having minus sine 2 theta upon 8. This is actually 4a. Okay, so this is what we will be having if you differentiate it. So sorry, I am differentiating. Okay, if we differentiate, we will be having minus sine 2 theta upon 2a. Okay, 2 and 4 will get cancelled. Okay, now after doing this, we will need to use the condition at an apse. R is equal to a, so therefore u will be 1 by a. And also we will be having that du d theta equal to 0, but also we can assume that the initial line is drawn, the initial line it's drawn at the apse only, so that is why theta will be equal to 0. Okay, this line, okay, is, if we assume, if the initial line is the line joining the apse and the pole. Okay, so what we will do now, we will substitute it in equation 2 and equation 3 to get the values of a and b. Substituting in equation 2, so u, it will be equal to 1 by a. Theta will be 0, so a cos 0 will be 1, so it will be a. Sine 0 will be 0, plus 3 by 4a. Cos 0 will give you 1, so it will be equal to 1 by 4a. So if you solve this one, it gives you that a will be equal to 0. Okay, 3 plus 4 will be 1 by a. Okay, so that is what we are getting. Substituting in 3, if we substitute in 3, du d theta, it will be equal to 0 from this condition. Minus a sine 0 will be 0, plus b cos theta, so it will be b, since theta is equal to 0, and this one will be 0. So it gives you that b is also equal to 0. So therefore, u, okay, it will no longer be a cos theta, since a and b are both 0. So u, it will be this. So this is what we are having. Okay, ultimately the solution becomes like this. A and b has become 0. So this is the part of the particle. Okay, but let us see the question. Okay, we need to convert it into r. Okay, but okay, we need to convert it into r. So 1 by a. 1 by r. 1 Okay, just let me do the calculations properly. Okay, so over here, we need to convert it into cos square. Okay, so cos 2 theta, we need to convert it into cos square. So keep that in mind. Okay, I can even write it down. 1 by 4a, 3 plus cos 2 theta, cos 2 theta equal cos square minus sine square. Okay, so if we change everything to cos square, will be 2 cos square theta minus 1. This is what we are having. 1 by r, 1 by 4a, 3 minus 1 will give you 2. You can take common 2. It will be 1 plus cos square theta. So cross multiply and cancel. You will be having 2a equal r, 1 plus cos square theta. Okay, so let's hope that that is what we need to get. Okay, indeed. Okay, so which is the required part? Okay, so we have solved the first part of the question. Now let us take a look at the question, the second part. And we also show that the time of complete revolution is 3a power 3 by 2 pi upon root mu. How exactly do we find the time of revolution? Okay, because remember that we have the pole, and this one is the initial line. So the particle is maybe traveling in this way, okay, in any kind of orbit, and the angle will change from 0, and if it travels the whole path, the angle has become from 0 up to 2 pi. Okay, so that is what we need to use. And also, since we need time, which of the following equations do we think we will have to use? Okay, which of the following equations do we have to use if we need time? Okay, actually equation 3. Okay, so equation 3, it involves time because theta dot is d theta dt. Okay, so keep that in mind. If it is a question about time, we have no other choice but to use equation 3. Now, okay, second part, theta dot equal hu square. Theta h, I forgot the value. Okay, how much did we get h equal to? I think h, it was this value, if you remember, 2 mu upon 3a, and u square will be 1 by r square. Okay, so this is what we are having. Now what will we do? And r square, if we use this formula over there, so theta dot, okay, I can write it as it is, 2 mu upon 3a, 1 by r square, 1 by r square, so will be, this one will be 1 by 2a, 1 by 4a square, 1 by 4a square, and over here it will be 1 plus cos square theta whole thing square. Okay, using this equation, okay, equation 4. So this is what we are having. Now we will write this one as d theta dt, but if you write it as d theta dt, all terms containing theta will be over here. So I will write it as 1 plus cos square theta whole thing square. These are all constants, so I will keep them as they are. I will be having 1 upon 4a, 2 mu upon 3a dt. So this is what we are having. Next, what we will do, we will have to integrate. So the time of complete revolution, let it be t, 0 to t, since the time we always measure from 0. And over here, this one will be from 0 up to 2 pi. Okay, let us name this one as equation 5. Okay, so the only problem now is how do we integrate this? Okay, since we are basically done, this one will become t. So now let us just integrate this. Let I 0 to 2 pi d theta. In fact, I won't even put the limits. Okay, it will only be confusing. I will substitute the limits after. Cos square theta whole thing square. So how do we integrate this one? You need to remember the technique. You will first have to convert everything into sec. Second, sec square theta whole thing square. Okay, since this is an easy step, okay, I've actually calculated it. I will just copy everything from the sheet that I've written. Okay, so it won't change. So this one will become integral d theta sec square theta plus 1, and over here sec square will go up, so you'll be having sec square theta whole thing square 1 plus sec square theta plus 1 whole thing square d theta, but sec square theta is equal to 1 plus tan square, so that is what I will write. And if you do the same over here, you will be having 2 plus tan square theta whole thing square d theta. Okay, so once you are done with this, now we actually have to perform some substitutions. If you substitute, we will try to make this look simpler. So we will put the substitution will be let tan theta. So since it's squared, okay, I want to simplify it. I will write it as root 2 tan z. Okay, we can differentiate everything, so it will become sec square theta d theta equal root 2 sec square z dz. So d theta, it will be root 2 sec square z dz upon sec square theta. But also, we need to convert everything back into tan. Root 2 sec square z dz, sec square it's 1 plus tan square theta, and tan square theta is equal to this. Sec square z dz, 1 plus tan square will be 1 plus 2 tan square z dz. So this is what we are having. So now we just need to substitute everything here, and we will be having this. Okay, so we will be having 1 plus tan square, it will be 1 plus tan square theta will be 2 tan square z whole thing square, and over here in the denominator we will be having 2 tan square theta will be 2 tan square z, again whole thing square, and d theta has changed into this root 2 sec square z dz 1 plus 2 tan square z. Okay, so this one and this one will get cancelled, one of them. So we'll be left with this, and root 2 you can take it outside. Over here you can take common 2. If you take common 2, it will be 2 squares, so you will be getting 4. So you will be having 1 plus tan square z whole thing square sec square z dz. But again, 1 plus tan square, it's equal to sec square. So you can cancel one of them over here. So you will be left with this. It is actually a very long integration. Okay, but if you are familiar with the theory of integration, you won't be having a problem with this central orbits. So this one, now we will convert everything to sine and cos, because that way it becomes easier to integrate. Okay, so this one will be 1 by sec square will be cos square plus 2. Tan will be sine by cos, so will be 2 sine square z. So this is what we are having. If we split this fraction, 1 by sec will be cos, tan by sec will be sine. Convert everything into sine. Okay, so cos will be 1 minus sine square plus 2 sine square z dz. So this is what we are having, root 2 upon 4. So you will be having 1 plus sine square z dz. Again, if you remember how do we integrate sine square, it is actually by using the formula again. So it will be integration dz plus sine square, you can write it as 1 minus cos 2z upon 2 dz. So this one will give you square root 2 upon 4 z plus 1 by 2 dz will give you z upon 8. Okay, 4 into 2 will give you 8, and minus square root 2 upon 8. Integration of cos will give you sine 2z upon 2. Okay, which ultimately gives you sine 2z upon 16. Okay, so this is what we are having. So this is the complete integration. Okay, you will even have that constant, but I am not writing it down. Okay, because after substituting the limits, the constant will get eliminated eventually. Okay, you can write plus c if you want to. Okay, so over here will be, and if you remember, the limits were from 0 to pi. Okay, and because of our substitution from tan theta to tan z only. Okay, so from tan to tan, so the limits they won't change. Okay, because it is from tan to tan only, from 0 to 2 pi. Okay, if you substitute, okay, do the same calculations, you will be having the same thing. Okay, so so therefore integration 0 to 2 pi 1 by 1 plus cos square 1 by 1 plus cos square x whole thing square dx. You just need to substitute the limits over here. It's 0 up to 2 pi. Again, the limits won't change. So if you substitute the limits 2 pi and 0, you will be having root 2 upon 4 into 2 pi plus root 2 upon 8 upon 2 pi, and over here will give you 0 minus root 2 upon 4 into 0. Okay, minus 0, everything will become like this. So now we just calculate it. So root 2 to 2 pi, you will be having 1 by 4 plus 1 by 8. Okay, we can take common this one. You will be having 1 plus 1 by 2, so you will be having 3 by 2. 2 will give you 6 by root 2 for 2 will be 8 to 3 by 4. So the value of on the left hand side of that integral that we had performed, it is 3 pi by 4 root 2. Okay, so next what do? We just have to substitute everything over there. Therefore, I think it was equation 5 or equation 6 depending. Okay, so we will be having the left hand side, it was that integral, so 3 pi upon root 2 4, and the right hand side, whatever it is. Okay, and remember that the integral was from 0 to t dt, so it will actually turn into t. You just do a bit of simplification, putting everything, the values over here that we have got from equation 5, and then you can just find out t. You will see that it will become that time of complete revolution. Okay, so t, you will be having 3a 3 by 2 pi upon root mu. Again, I repeat, so what had we learned over here is that the technique differs when the force is also a function of the angle theta. Okay, and also that if you have a proper background of integration, you won't be finding these problems that difficult. Until next time.